Okay, so welcome to another video. So today we're going to be looking at the basic forces and motion in the mechanics AES module. So what I need to do is pause the video and have a look at this prior knowledge check. Okay, so here's the answer. Question 1, question 2, this size and the angle, question 3, and 3 part B. Okay, so with mechanics, we always need to understand what the diagram will look like. Mechanics is a simple rule. You have to draw the diagram and show where all the forces are acting. So let's take a block and we'll say the weight of W is pulled along right by force P. So when we draw that diagram, we'll have the weight, which is acting downward like this. Yeah. We'll have a normal reaction going up, perpendicular to the surface, and we'll have a force P going to the right. And the opposite of direction of motion will always be the frictional force. And if the surface is smooth, then the frictional force is 0. In this case, there's nothing going opposite direction of motion. So let's take this example here. So we've got these forces acting on this particle. So we asked to work out the resultant force and describe the motion of the particle. Now if we look at the horizontal left and right, we'll see it's actually equal to 0, because 20 to the right, 20 to the left. But if we look at up and down, okay, we could see there's 30 going up and 10 going down, so the net force vertically will be 20 going up. So we say the particle is accelerating vertically upwards. So it's important to note the resultant force in a particular direction will cause acceleration in that direction. And if there is no resultant force, then the particle could be stationary or moving at constant velocity. Now that's important to understand, because although an object has no acceleration, okay, it could still be moving with constant velocity. And sometimes we could be given this in the vector notation I and j. So we're told these are the forces 2i plus 3j, 4i minus j, minus 3i plus 2j, and another one which is xi plus yj act on an object, and the object is in equilibrium. And we asked to find the value of the coefficient of x and y. So we need to set this equation and equal it to 0. And then if you just simply collect the i's together and the j's together, we know the I components are 0, the j components are 0, so if we tidy up the I components, 3 plus x equal to 0, which means x will equal to minus 3, and for the j component, 4 plus y equal to 0, so y would also equal to minus 4. So in this example, we're told a particle begins at rest at the origin and is acted by 3 forces, 2i plus j, 3i minus 2j, and minus I plus 4j. And we asked to find the resultant force in the form pi plus qj, and also to work out the magnitude and the direction of that resultant force. And we also need to describe the motion of the particle. So since we are given 3 forces, first of all we need to work out the resultant force, and that simply will be just the sum of all 3 vectors, which gives us 4i plus 3j. Now to work out, if we draw the diagram, 4i plus 3j, so to work out the magnitude, it's just a simple 3, 4, 5 triangle. So use Pythagoras theorem, or if you just know the idea, this is a 3, 4, 5 triangle. So now we've got the magnitude, we simply use the angle theta. So it is trigonometry, tan theta 3 over 4, so theta will be 36.9. So remember, bearings are measured from north and you measure clockwise, so we simply just get 53.1 or just 53,053. Okay, so now we can see the particle is accelerating in the direction of the resultant force. So now what we're going to look at is Newton's second law of motion, F equal to ma. So the force acting on an object F equals to the object's mass multiplied by its acceleration. And no acceleration, i.e. constant velocity, means there will be no force. So think about it, if you're in a car, if the car is traveling at a constant speed, so if you're driving 30 miles per hour and you continue to drive at 30 miles per hour, you don't feel any force. As soon as you start to accelerate, you could feel you're going back, because now you could start feeling the force because you're accelerating. Or on the other hand, if you're slowing down, you're applying your brake, you move forward because you're feeling the force. And the other thing to remember is weight is actually a force. So when we say weight, weight is the mass times the gravity. So a lot of people get quite mixed up between weight and mass. So for example, if you ask somebody's weight and they will say, oh, I'm 65 kg, well, that's not actually the weight they're referring to, is the mass. Okay, so your weight varies where you are. So your weight on planet Earth will be different to your weight on, for example, on the moon. But your mass is always the same. Your mass doesn't change.
Yep.
So let's say we're asked to find the weight of a mass of 12 kg. So it's just simple substitution to this formula, 12 times 9.8. So our weight will be 117.6 Newton. So weight is a force, so to too significant, we could say 120 Newton. Here we are given the mass and the weight, or the force in this case, and we're asked to find the acceleration. So again, if we just plug into the formula, 6 equals to 1.5a, so that will give us the acceleration of 4 meters per square second.
Yeah.
Okay, so if we take this example here, we are asked to find the missing values of x and y. So the first thing you want to do is look at everything going horizontally and look at everything going vertically. So if we resolve it horizontally, F equal to ma, so we're going to just follow the direction of the acceleration as our positive. Because in that case, you don't need to worry about changing the sign for acceleration. If we just follow which way the acceleration is going. So acceleration is going to the right, so I'll just say x minus 4, which is my forces, is equal to ma. Now m is 2, acceleration is 2, so 2 times 2, and that will give us 4, so the x value here is going to be 8 Newton. If we resolve it vertically, well, vertically there are no acceleration, so you're free to choose whichever way you want to resolve this. So if I just say going upward as my positive, so y minus 2g is equal to 2 times 0, which is just 0, so straight away we could see y is equal to 2g, or 19.6 Newton. Okay, so let's take another example. Same as before, but this time acceleration goes to the left, and we've got this additional force 20 Newton pushing down the block. So why don't you pause the video and have a go at this. So now if we resolve it horizontally, again we're going to follow the acceleration as our positive. So 80 minus x is equal to ma, 4 times 2. So that would give us the x value of 72 Newton. Now if we resolve it vertically, again vertically there's no acceleration. So what we have to do is just say y minus 20, because 20 is going in the opposite direction to y. Y minus 20 minus 4g is equal to 0, 4 times 0. So now, if you work that out, make y the subject, it will give us 59.2 Newton. So let's take another example. So we're told a block of mass 5 kg is pulled along a rough horizontal table of force of 20 Newton, and the frictional force is 4 Newton acting against it. So we're told that this starts from rest, and we're asked to find the acceleration of the particle at the distance traveled in the 4 seconds and the magnitude of normal reaction. So as in mechanics as usual, we start off by drawing a diagram.
Yeah.
So we've got our 5 kg block. So the weight 5g is a force acting downward. We have a normal reaction. We've got the pulling force of 20 Newton, and we've got the frictional force of 4 Newton. So same as the previous slide, to work out the acceleration of the particle, we'll know the acceleration will go to the right, because to the right is 20 Newton, it's greater than the 4 Newton. So if we substitute into the formula F equal to ma, we'll have 20 minus 4 is equal to 5a, and if we work that out, it gives us the acceleration of 3.2 meters per square second. Part B of the question is asking us to find the distance traveled in 4 seconds. So straight away, you know there's a suvat coming up.
Yeah.
So the distance is what we're looking for. It starts from rest, so u is equal to 0. V we don't know and we're not interested. A we've just worked out is 3.2, and time we're given in the question, which is 4 seconds. So in this case, we need to use this formula, S equal to ut plus half at squared. And if we substitute into the values, okay, and that gives us the distance traveled of 25.6 meters. Now part C says the magnitude of the normal reaction. So it's just asking to find the R. So we know vertically there's no acceleration. So we simply just say R minus 5g is equal to 0. And if we take 5g on the other side, so that'll give us the magnitude of normal reaction of 49 Newton.